Alright, kiddos, I am trying to show you how to graph linear inequalities. So our objective today is to graph the solution set of linear inequalities in two variables, which means like the x and y, on the coordinate plane. Now, in this case, we will always say y, helps if I'm using the right thing, y something in terms of x and y, or y and x. I should actually say x and y, so let's try that again. X and y. We can't use f of x because when we go to inequalities, for some reason we cannot use f of x. And you'll see that when we go to the calculator and use it on the Inspire. Anyways, you might want to make sure you copy this down. If you've got no line underneath, make a dashed line. If you got a solid line underneath, make a solid line. Doot, or shoom. Shade below, or if it's x equals x whatever, shade to the left. Or shade above, shade to the right. And you'll see what we mean with the first example. I would recommend pausing here because I will go to the next slide, so go ahead and pause if you need to copy this down. Alright, so here's our first example. Y is greater than 2/3 x minus 5. Now we start this off just like we did normal graphing, which means we're going to start with the y-intercept, which is -5. 1, 2, 3, 4, 5, down. Then we're going to use a slope that says to go up 2 and over 3. Up 2 and over 3. Up 2 and over 3. You can see how I counted. You can count yourself. Up 2 and over 3. Now, then you start working now, right when we start to make the line, this is where you would have to think about the inequality. Notice there is no line underneath. This is just a greater than symbol. So this says I need to make a dashed line. So there you can see my dashed line. What that means is any point on that line will not count. If it's on a solid line, you count it as a solution. Okay, and then we want to shade greater, so greater is above, so let's shade all the greater. Now what that tells me is that any point in this area, in this shaded area, would give you an answer that would give you greater than, like the left side would be greater than the right side. So like if you took a point, let's say 3, this is -3 and +1, well you put that in there, 1 is greater than 2/3 of -3 minus 5, and what you're going to get is 1 is greater than -7, which is true. So you know that point works. Whereas if you choose a point here, 1, 2, 3, 4, 5, 6, down 3, and let's say +6 but -3, and put that in there, you would have -3 is greater than 2/3 times 6 minus 5, which gives you, that's 2, 4 minus 5, -1, which is -3 is not greater than. So, not true. So you can see any point in here, in this shaded area, would be considered a solution, whereas any point outside of it wouldn't. And with inequalities, we're basically dividing this into two sections. Alright, so the next one would be -5 plus 2, -5x plus 2, which is just I start at 2, go down 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and over 1. Down 1, 2, 3, 4, 5, and over 1. Okay, and so if you make this one, according to this, we should make this into a solid line. So let's do that. And something like that. Okay, now supposedly with this we want to say shade below. Okay, so we did the y-intercept, we used the slope, and then we did this, the line told me solid line, now I want to shade below. Sometimes the question becomes, what is shade below? Well, again, the idea here is, and I always go to the y-intercept. Let's take a point right here and right here. Is this below this point right here, or is this below the point here? Well, obviously this point right here is below the y-intercept, so then that means this whole area is what I need to shade. So shading, 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 and again, all those points in the shaded area are considered solutions, and so is any point on the line since it's a solid line. So that's a quick example of those. Let's look at some more. Here's one that's in standard form. They might suggest that you would have to say solve for y on this, but my opinion, what you need to do here is just use your intercepts. 6 divided by 2 is equal to 3, so that's 3 comma 0. That's my x-intercept, 1, 2, 3. 6 divided by 3 is equal to 2. That's my y-intercept, like that. This is a broken line, so we're going to make this into a broken line. And then this is shaded below, so I'm going to shade below. Now, the only problem with this when you want to use the intercepts to graph is you have to be careful that if it's got a minus in front of the y, you need to make sure that you switch the direction of the inequality. So, for example, let's say I had 3x minus 4y greater than equal to, we'll say 12. Keep it easy. Okay, the x-intercept here would be 4. 1, 2, 3, 4. The y-intercept would be negative 3. 1, 2, 3. And it is a solid line, so we're going to make this into a solid line. So notice how I'm approaching this. I'm not changing my idea here. I'm just going about this in a way that allows me to do this. Now, here's the thing. Normally this would be greater than, so I would shade above. But if you test this out, and actually because of this minus, and you would end up, if you were solving for y, you would actually end up like doing the opposite. So because of this minus, this actually is going to switch if you were solving for y. So you should actually shade below. Now you can test this out by saying, let's take a point here. Let's say right there. 1, 2, 3, 4, 1, 2. This is positive 4 to negative 2. If you put it in here, it should give you an answer greater than 12. Well, let's see. 3 times 4 minus 4 times a negative 2 gives me an answer of 12 plus 8, which is 20. And 20 is greater than 12. So I have confirmed it. This point works. That means any point in the shaded area would work. So there's that, and there you go. Okay, one quick example about x being less than or greater than a number, because I did mention that about shading left or shading right. Let's say x is less than 4. Okay, so this tells me at 4 I should have a broken line. It's a vertical 1, 2, 3, 4. So something like this. Okay, and then the idea is this says shade to the left, so I would shade all of this, and there you go. So that's what I mean by shade left or shade right, and this only involves a vertical line, which is when x is some number. Okay, so there's that. My final thing I want to cover is coming up with the equation of the line from the graph. Now notice how I also talked about solutions. Realize again, each and every point that you can find here is considered a solution to the inequality. In other words, they would be numbers or points that would make a true statement where the left is something to the right. In this case, like greater than or equal to. Alright, so for this last example, I want you to be able to come up with the equation of the line that would be, or I'm sorry, the inequality that would fit this graph. Well, let's identify a couple of things here. Like one, we have a y-intercept, helps if I'm writing with the right thing, y-intercept of 1, 2, 3, 4, negative 4. You have a slope, 1, 2, 3, 4, 5 over 1, 2. So slope is going up 5 and to the right 2. So that means then I have something like this, 5 over 2x minus 4. Slope, y-intercept. Now, this is broken, so I don't need a line underneath, and it's below, so that means it would be less than. And that's that. So you get the idea of what you need to do here. This is covering graphing linear inequalities, and we will spend the week on this. So if you do have any questions, feel free to let me know. Thank you very much.